Hello everyone, hope you're doing well. Welcome back to my channel. Today we are at day 25 of the January daily lead code challenge, and we have a very good question in front of us. This is the exact level of question that you can expect in a FAANG level interview. Okay, at least see in a FAANG level interview, we have multiple questions. At least this kind of question you can expect in the round one because this is a very nice question. The level is very good. Okay, so if you want to see the complexity, see this part. Only the acceptance rate around 55%. This acceptance rate in lead code is considered to be a very good, I will say level. Even hard questions will have sometimes this much level of acceptance rate. Okay, so this you can consider it as a hard level question. Okay, that is fine. Concept is easy. Again, the test cases are slightly easier, but yeah, this can be considered as a slightly harder level question. Okay, that's what something I want to tell you before I begin with. Okay, this could be the level you can expect in a FAANG level interview. So this is something that I want to tell you before starting this question. Now coming to this question, it's going to be very good question. Please pay attention, learn everything involved here. It's a totally new topic, I will say. Like, see, the idea is new. Again, you can solve it without even knowing the idea, but just want you to know this topic. It's called a disjoint set union. Some people also call it as a union find. Okay, so like just google it out, what are these terms, and try to learn something about them. So remember, this is just an idea, right? It's just an idea. It's not like any algorithm is being involved here which you should know, otherwise you can't solve. It's not like that. It's just an idea, just an approach. Okay, if you know this idea, it will be very easy for you to identify whether this question applies, this question contains this particular topic or not. Okay, as simple as that. Or whether this topic applies to this question or not. It will be easy for you to understand why I am saying this. Okay, so just google this topic out, and yep, these are the two like same words for this allows. Okay, so just google them out. You will get a clear picture of what is happening in this question. Okay, remember, again I will say, this is not algorithm which you should know. Without that you cannot, not like that. This is just an idea which you should know, right? Yep. Now coming to this question, 2948, make lexicographically smallest array of swapping elements. Okay, so what is lexicographically? We'll come to this term. Okay, this term you don't have to worry much. This term is, I guess, in LeetCode multiple times this term is getting used, like lexicographical sorting, all that. We'll come to that. They've actually given a lot of examples also for you to understand. So we'll come to that, like why this first one of differences considered for lexicographically sorted string. We'll come to that. It's not a very hard topic to understand. Main focus should be on learning what are these topics. Okay, that is the main aim of making this video, right? Now coming to the question, see this part, what and all we are given. So we are given a nums array. Okay, let me zoom in so that it becomes very clear to you. Yep. So we are given a nums array. Okay, and we are also given a limit. Okay, if you see the constraints, nums array is going to have a length of around 10 power 5, which is really a big one. Okay, this really big one. And yeah, each element can be in the range of 10 power 9. Okay, 1 to 10 power 9. Right? Similarly, limit also is same as that of the each element. It is going to have a range of 1 to 10 power 9. Right? Now coming to the question, what is happening? See this part. What is going to happen is, you can replace, like yep, let me use the term replace. What you can do is, see, you can interchange. Okay, let me use that term, interchange 1 to 3. For example, say I want to interchange 1 and 3. Okay, this can be interchanged if the difference between the two is less than or equal to the limit. Okay, for example, here 1, if I do subtract it with 3, remember I have to take the absolute value. Okay, if the absolute value of the difference of 1 and 3 is less than equal to the limit, then I can solve them. Okay, I can solve them, I can interchange them. So if you see 1 and 3, you subtract them, the absolute difference is coming as 2. Okay, since 2 is less than equal to 2, so they can be swapped. Okay, that is the basic idea. So in this question, what you have to do, you have to swap these numbers like the way I mentioned. Okay, only two numbers can be swapped if the absolute difference is less than the limit. After swapping any number of times, whatever ensures that this, you have to get the lexicographically shortest string. Okay, as simple as that. Okay, lexicographically smallest string, right? So this is the question, and I just explained in my words. So let us see the exact words which they are mentioning. Okay, you are given a zero indexed integer array of positive integers. It's called a num, and yep, and they've also given a positive integer called an event. In one operation, you can choose any two indexes. They are calling them as I and j. Let us say we're choosing index I and index j, and you can swap the values in them. Okay, that is nums of I can be swapped with nums of j if you see the absolute difference of them is less than equal to limit. What is the absolute difference? Absolute means, in maths you would have learned the topic of mod, right? Mod basically means, it's, see, uh, it doesn't matter which value is bigger, which value is smaller. Okay, it doesn't matter. For example, 3 and 5. So if you do 5 minus 3, we'll get a positive number. If you do 3 minus 5, we get a negative number. But that doesn't matter. So what we do is just remove the minus sign, and if there is no minus sign, simply ignore. Okay. So if after doing that, if the number is less than equal to limit, in that case, only in that case you can swap them. Okay, that is the basic idea. Return the lexicographically. Okay, lexicographically smallest array that can be obtained by performing the operation any number of times. So see, my advice to you, will you please learn this term. Okay, this line is very important. Like, I guess in multiple lead code questions, this term will be coming, and especially in string related questions, I have seen this term very often. So what is lexicography? We'll see in just alphabetical order, but the difference here is, for example, if you see, they've given a very good example. See this case, it is 2, 10 and 3. Okay, and it's 10, 2 and 3. So what will happen? See this part. See, it's all about the first point of reference. That's what I'm saying. Let us say array is there, okay? We are claiming that it is lexicographically smaller than array. So what it means, that means that at the first point of difference, okay, A is having a number which is smaller than the number present in B, okay? So this part, array A has element that is less than the corresponding element of B, okay, at the first point of difference, okay? For example, take this array 2, 10 and 3 and this thing. So what is happening, see this part, the first point of difference in this, okay, it's index number 0, okay, because here it is 2, here it is 10. So since 2 is less than 10, we can claim that this whole array is lexicographically smaller than this B, okay. Let us say the first two terms also matched, then the difference will be in terms of this index number 1, okay. If the zeroth index is matching in both the arrays, you have to compare the index number 1. If the index number 1 is also matching, you have to compare index number 2 and so on. So whichever is the first point of difference in that index, whichever array is having the smallest element, that will be lexicographically smaller than the other array, okay, as simple as that. That is the basic idea. So see, they are different in index number 0, and since the array A is having 2, the array B is having 10, since 2 is less than 10, that's why this particular array will be called lexicographically smaller than this particular array, okay. So yep, this is same as alphabetical order, this same as the numerical order, everything is same, but only thing that you have to understand is it's all about first point of difference. Wherever the first point of difference coming, starting from left towards right, in that place, whichever array is having the smallest value, that will be chosen first. That will be considered as the smallest value compared to the other value, okay? Yep, that is all about the lexicography. You can just again Google this out. I have given a good example, but still, if you're not clear, if you're seeing this for the first time, I will definitely advise you to like just do a Google search. It will give you multiple examples. Even this example is good. Just remember this word. You have to start from left towards right. See, you are comparing two arrays, so you have to start from left towards right. Where is the first point of difference? At that place, whichever array is having the smallest element, that will be called lexicographically smaller compared to the other array. Okay, that is the basic idea, right? Now, if you see this case, this is the question given to us and this is the answer for that, okay. That they are claiming that this answer is the lexicographically smallest string possible for nums, providing we are only interchanging, that is we are only swapping two values such that their modulo difference is less than or equal to limit, okay. Now let's understand what is happening. So see, like the first thing, if you're given, let us say we are at a FAANG interview, okay, and we are given this question, what is the first thing that should come to your mind? Like many of you will say that, even for me it happened that what I thought is, okay, let me think about bubble sort, like the way bubble sort is implemented, okay. Let me think about that, okay. That is a very good idea actually, because see, it's all about swapping, right? You are also talking about swapping, but this is a new thing, this limit is a new thing obviously, but still you are talking about swappings. So the first thing that can come to your mind is bubble sort, because it's almost same what we are doing. But see the constraints here, bubble sort will take around n square time, right? So we are having a very long input. We cannot afford open solutions. That's the first thing. Second thing is that, see, in if you remember bubble sort, what is happening, we are only comparing and swapping adjacent cells, okay, adjacent values. In this case, that it is not the case, because see, they're claiming that any two indexes, remember the word any, the word any is very very important. Remember, any two indexes, ing, remember ing need not be adjacent, okay. Ing can be any two indexes. That doesn't mean like it need not be adjacent at all. Only thing that you have to understand is that the modular reference of the values in those indices has to be less than or equal to limit. So that's the reason why, see, bubble sort is a good thing to do, but not in this case, because bubble sort is very, see, restricted about, it is comparing only the adjacent elements, okay, and swapping them. We don't need that here, but it's good that you have got this idea, but again, this is not needed here. Maybe you can try that as a brute force solution first, but if you are talking about optimal solution, that will not be useful, okay. As simple as that. Now how to do that? Now I will try to teach you the idea of what is disjoint set union, okay. So idea here is, we are now going to union the values which are going to fall in a common set, okay. As simple as that. The idea here is, let us say one element doesn't fall in the set, that we will create a new set for that, okay. So that is the idea behind that, and that is why it's called union find, okay. So we are basically going to the union of multiple sets, right? So let us see now how it works. So I will teach you with example number 2, because see, example number 1 is very very simple one, okay. Here most of the elements are, if you should do the difference, they will be falling with less than or equal to the limit. That's why I don't want to take this example. I will take example number 2 onwards, okay. So see, this is the example number 2. Let me zoom in. Let's quickly begin, okay. See, I have kept the example number 2 in the left side, and I have given, yep, my tracing output in the right side. So I'm talking about example number 2, and this is the nums array given in that, okay. Yep. So the limit here is C 3, okay. Now first thing that we'll do is try to understand this fact. See, one thing that I want to teach you before that is, see, for example, I have three elements, okay. Let us say 1. Okay, let me start with 5, and then 3, and then 1, okay. Now let us say the limit equals to 2, okay. Limit equal to 2. So can you quickly tell me whether 5 and 1 can be replaced, swapped, okay. 5 and 1 can be swapped. So direct answer to that will be no, but your indirect answer will be yes. Why? See, 1 and 5 cannot be directly swapped. Okay, see this part, 1 and 5 cannot be directly swapped, because if you see, like, if you learn about these conditions and all, you will get to know that if you subtract 5 and 1, you are getting 4. Okay, absolute difference is 4. 4 is obviously greater than equal to limit, so it cannot be swapped. But see a case here, I can swap 1 and 3 because their absolute difference is less than equal to limit. And then see, after swapping that, what will happen? See this case, it will look like this. 5 will remain as it is, then 1 will okay, before that, see this case. See, the idea here is you can replace any two values. Okay, you can any two indexes. Okay, so we'll now apply that. So remember, 1 and 3 can be swapped. Do you agree with me? 1 and 3 can be swapped. Similarly, 5 and 3 can be swapped. So the idea here is, ultimately, since 1 and 3 can be swapped and 3 and 5 can be swapped, that means 5 and 1 can also replace their positions. How we will see that? Let us see, we are first changing the values between 5 and 3. Okay, what will happen? 3 will come here, 5 will come here, and 1 will remain in its place. Okay, now, since 1 and 3 can be replaced, so what will happen next? It will happen next that what will happen? 1 will come here. Okay, 5 will remain as it is, and then 3 will come here. Okay, as simple as that. And again, after that, you can again replace, swap 5 and 3. What will happen next? It will look like this: 1 will be there, then 3 will come, and then 5 will come. So the idea here is, if you try to understand what is happening, we are basically trying to find a union. That is, once a number of elements are there in the union, they can be swapped with each other. Okay, it doesn't matter what their values are now. Okay, because we have to just look for a property such that they can be included in a union. And once the elements are there in the union, we can conclude that yes, we can swap any elements in that union. Okay, as simple as that. So now our question reduces to how to find this union. Okay, do you accept this fact? See, number is 1. If you subtract, say, 1 and 3, definitely they can be replaced with each other. Similarly, 3 and 5 can be replaced. So if you learn about the transitive property, we'll get to know that even 1 and 5 can be swapped, and that we have proven it here. Okay, so this is the same property that we are going to try now. Okay, so for that, what you have to do is see this. See, if you directly compare, as I mentioned, you cannot swap. But yeah, there are number of intermediate steps, and after that, it can swap. So for that reason, what we are going to do is we are going to sort the numbers. Okay. Remember, since the indexes are also important, we'll have to maintain their indexes also. So if you see, for each number 1, okay, what I'm doing, I'm maintaining a, this is called a tuple in Python. Tuple basically means it has more than one element here. Okay. See this case, tuple basically means, like, if you see this arrow, like, this particular bracket, right? This basically means a tuple. It's like treated as a constant, but we can store any number of elements in that. Okay, just like a list, right? So see this case. See, this is the number 1. Okay, its index is 0. So I will write the number 1 here, and its index will be mentioned here. Okay. Similarly, if you see the number 6, okay, number 6 will be written like this, and its index will be written like this. Okay, so that is the idea here is, in each tuple, what will happen? The zeroth element is going to be the index, and the index number 1 is going to be the value. Okay, that is how you have to represent it. So what we are going to do, we are going to sort it out in such a way that we are also capturing the indexes. Okay, so this is the sorted value. Okay, see this case, this is a sorted value. What it means, first 1 will come. Okay, this is the smallest value, then another 1 is there. Okay, this is the second smallest, then 2 will come, then 6 will come, then 7 will come, and then 18 will come. Okay, now what we'll do is, now we are trying to form groups. Okay, this group is what we are calling as unions. Okay, this is what we are calling it as unions. Okay, as simple as that. So now we are starting our algorithm. So see, please pay attention. See, my aim is to teach you the idea theoretically. The way you want, you can code after that. Okay, just know the idea, just know the approach, and then whichever way you want, you can code it out. Okay, because Python provides you a lot of flexibility to code on your own. Okay, you don't have to, like, follow a particular data structure and to, like, code it. You can do any way you want, but just know the approach. So see, this is going to be a groups. The groups is going to look like this. This single thing is called as a group. Okay, see, this is the final answer, but I don't want to show the final answer. I will trace it out, and I will show you how this answer is coming. Okay, at the first step, what you have to do, what is the first value? Okay, write it here. Okay, and similarly, whatever is the index for it, simply write it here. Okay, so see, the idea here is, this is called as a group. So this bracket, what you're seeing, right, this bracket is going to capture a group. Okay, inside that, some more elements will be added. This particular bracket is going to store all the values in that group. Similarly, this bracket is going to store all the indexes in that group. Okay, that is, the value belongs to a certain index, right? So the indexes will be stored in this particular group, and the value will be stored in this particular group, and both of them, okay, both of them are going to be part of this particular group. Okay, let's see that. So each group will have basically two values. Okay, the value index number 0 is going to store the values, index number 1 is going to store the indexes. Okay, it will become more clear when I do the testing. Okay, so I have already included these things in my here. Okay, so I will start from index number 1 now. Okay, so for the index number 1, what is the value is 1. So I will just check for the last entered value. Okay, for the last entered value, whether if I subtract this and this, whether that's absolute modulo difference, whether absolute difference is less than or equal to limit or not. Okay, so in this case, 1 minus 1 is 0, which is less than or equal to limit. So in this case, this particular number will also be part of this particular, okay, a group. Okay, this particular group. So what I will do, see, now I'm processing this. So what I will do, I will write 1 here. Okay, I will write 1 here, and its index 5 will be included here. Okay, this will be included here now. Okay, this will look like this. Now we'll come to the next value, 2. So 2, right? Now 2, I will subtract this from its previous value. Okay, if you see, remember they are sorted. Okay, 1 1 2. Okay, they are sorted. This sorting makes it easy for us to understand whether they are going to be part of the same group or not. Okay, see, 2 I will take, the last value I will take 1. So 2 minus 1 is obviously 1, and it is less than equal to the limit. Okay, so for that reason 2 is also going to be part of the same group. Okay, so what I will do, I will add 2 also here. Okay, 2 is also part of this group, and I will add its index. What is the index of 2? It is 4. Okay, I'm adding it here. Okay, as simple as that. So index of 2 is 4, right? Now comes to 6. Now we are at 6. 6. Yep. Yeah, we are at 6 now, right? So after 2, the next value is directly 6. Okay, so if you now subtract 6 with 2, because 2 was the previous element, 6 is the current element. So if you do 6 minus 2, if you take the modular difference, it will be 4. Since 4 is not less than equal to the limit, we will now have to form a new group. Okay, I hope you're understanding what I'm saying. Okay, let me write it below so that things become more clear to you. Okay, this whole thing is a single group. Okay, like this, now we have to create another group. Okay, now we are going to create another group. As I mentioned, each group will have two parts. Okay, first one will store the values, second one will store the indexes. Okay, in this case, 6 is the value, 6 will be stored here, and 2 is the index, so 2 will be stored here. Okay, 6 is the value. Okay, and 2 is the index. So this I created a new group. Okay, this is a new group now. Okay, now comes to 7. Now we're at 7. So if you subtract 7 from the previous scene value, okay, in the sorted order, so 7 minus 6 is 1. 1 is less than equal to 3. So 6 and 7 are going to be the same group. So what I will do, I will add 7 here. Okay, I'm going to add 7 here, and the index for 7 is 1. Okay, so I will add 1 also here. Okay, yep, as simple as that, right? Now let us go to the next value now. So if you see 18, okay, 18 and subtracted from the previous value from in the sorted list, 18 minus 7, obviously it is not less than equal to 3. Okay, 18 minus 7, okay, is 11, which is not less than equal to 3. So again, this particular number is going to be part of another group. So what we'll do, we'll have to create another group now. Okay, so as I mentioned, each group will have two parts. First one will show the value, second will show the index. So since the value is 18, I will show here 18. Since the value, sorry, the index is 3, I'll show the index. So now we have three groups. This is the group number 1. In this group, we have these particular values, and these are the indexes for that. Okay, similarly, this is the group number 2. Okay, sorry, this is the group number 2. In this group, these are the values, and these are their indexes. Okay, similarly, this is the group number 3. In this, these are the values, and these are the indexes for it. Okay, so this is all about it. Okay, let me just comment out this, right? Now this is done. Like, how to get the answer now? Still we have not got the answer. How to get the answer now? See, it is going to be very, very easy now. So if you like, see, if you see my implementation, what I've done, these particular values, what you're seeing, right, the inner, this is the innermost, I can say, list. Okay, innermost array. This will be now as a heap. Okay, I will create this as a heap. So what will happen is, as you know, in a heap, what happens when you insert element in the heap? Okay, let us say when you pop element from the heap, always the smallest value will be popped out. Okay, so for example, see, why I have formed this as a union, why I formed this as a group. What it means is, any value in this group can be swapped with each other. Okay, do you get my point? Any value in this group can be swapped with each other. Okay, so wherever, let us go to example number 2. Yeah, if you see, wherever ones are present, see, this one and this one and 2. Okay, these are part of the same group. That is, I can replace any value with MSC. Wherever one and twos are present like this, wherever they're present in respect of the indexes, they can start with each other. Okay. So what I will do, I will try to ensure that since the lowest index in this group is 0. Okay. If you see what are the indexes, 0, 5, and 4. So I will ensure that the lowest index get the lowest value in this group. Okay. Similarly, the second lowest index get the second lowest value in this group, and similarly, the last index gets, that's the last index in this group, gets the highest value in this group. Okay. That is what I'm going to ensure now. Okay. As simple as that. So yep, let me finally write the answer here. Okay, I will write the indexes word. Okay, that means it will be becoming very clear to you. Yep. So how many indexes are there? Yep. 0, 1, 2, 3, 4, and 5. Okay, fine. These are the indexes. Okay, and these are going to be the values. Okay, let me just write IND. So that, see, this is just for your reference I'm writing. Okay, then we'll finally see the answer. And this is going to the value. Okay, yep. Yep. Okay, initially let me write 0 in all of them. So just as a placeholder, these are like, yeah. Now if you see, the smallest value here is 0, and the smallest value is 1. So what I will do, in the index number 0, you have to put 1. Okay, in the index number 0, put 1. Okay, as simple as that. Then in the index number 4, this is the second smallest index, put the second smallest value, which is 1. Okay, index number 4, go there and put the second smallest value. Similarly, go to the last index and put the last value. Okay, index number 5, you have to put 2. Okay, index number 5, I'm putting 2 now. In this case also we are going to do the same. In the index number 1, okay, go and put the smallest value in this group. Okay, 6. So index number 1 will now have 6. Okay, yep. Similarly, the second smallest value is 2. So the second smallest index is 2. In this we'll have the second smallest value 7. Okay, so just go to index number 2 and put 7, right? We're putting 7 here, right? Next, this is the only element in this group, so just simply go to index number 3 and put 18. So it is already there, I know, but this is how my implementation will look like. Okay, so this is going to be a final answer. If you compare this and this is how it will look like. So idea here is, see, in a group, okay, in a group, see, there are certain values in a group, and their corresponding index are there in the group. So what we're going to do is, in a group, I will just see which is the smallest index. In this index, I will put the smallest value in this group. Okay. So please try to understand this fact. This is what is a union, right? This is what is a group. Okay. So in this group, these are the smallest indexes. So what I will do is in the smallest index of this group, I will put the smallest value of this group. Okay. Similarly, in the second smallest index of this group, I will put the second smallest value of this group. Okay. That is going to be our implementation. Okay. As I mentioned, this part what I'm showing you highlight currently, this I have implemented as a heap. So when I'm popping the values, basically always the smallest value popped out. Okay, so you don't have to worry like how I'm getting the values. Okay, one by one. As I mentioned, see if you see after 0 5 is coming, but just to show you 5 is coming, remember internally it is a heap. So if you know the property of heap, it will always pop the smallest value first. Okay, this is a min heap. Remember that the minimum heap. So always the smallest value popped out. So by default after 0 4 will be popped out. Okay, similar here also by default after one the second one will pop out. Okay, as simple as that. So that is how we are going to do it. Okay, so this is going to be your final answer. Okay, and let me comment out this also. Yep, and yep, if you see, yeah, this is the final group. Okay, you can go through it. This is what I've written here. Okay, this is exactly what will be printed. Okay, yep, and let me comment out everything and let us quickly see the code now. Okay, I've kept some print statements so that when you are testing this code you can understand everything. Okay, you can understand every aspect of it, right? Let us go to the yep solution now. I've imported heap, right? Yep, then I'm just capturing the length of the nums. Then as I mentioned, I'm creating sorted nums. Okay, sorted nums, as you can see here, it will each element will have two parts. Okay, one will be the value itself and the second will be its index. Okay, so if you see what I've done, yep. So see, I'm going through every element in nums, and for that every element I'm creating the corresponding element like this. So this will have the value also, and this will have the index also, right? And then I'm sorting this particular array. Okay, I'm sorting this on the basis of this nums. Okay, on the basis of this num. If you see, I'm passing sort where key in the key I'm passing x of 1. So what is x of 1? If you see x of 1 is that for every this is whole thing is x, and it's x of 1 is this. Okay, so the sorting will happen based on the value, not based on the index. Okay, as simple as that, right? After that, I'm creating a group. As I mentioned, always in a group, one default value will be there. Okay, so this is the first group. Okay, remember the thing that I am highlighting currently is the group number 1. Okay, this is the group number 1. Okay, as simple as that. As I mentioned, in each group always there will be two parts. Okay, this is the first part where it will store the first value, and this is the second part where it will store the first index. Okay, as simple as that. Okay, so see, this is the sorted nums. Okay, I'm just going to sorted nums of 0. Okay, sorted nums of 0. In that sorted nums of 0, take the value. Okay, this is the value in the index number 1. So I'm writing index number 1 here. Okay, similarly, go to sorted nums of 0, and this is the index number 0. In the index number 0, we'll get the index. So this is going to be my groups. Okay, fine. Now next, what we are doing? Next, we are going from every element from index number 1 to the last index. Why from index number 1? Because for index number 0, we have already had it. Okay. For index number 0, we have already calculated this, right? So we are going from index number 1 till the last index. What we are doing? For the current index, what is the index? See, that is, see, I'm going in the sorted nums. Okay. In the sorted nums, in the index number 1, okay, I'm going to get this. Okay. Let us say this part. I'm going to get this. Okay. So if you see, this is going to be the index, and this is going to be, yeah, sorry, this is going to be the value index, and this is going to be the value. Okay, so what we are doing is, see, for that particular index in the sorted nums, first of all I'm going to capture the index. What is the index? See, just go to sorted nums of I, because we are at the ith index. Okay, just go to sorted nums of I and take the 0th value. The 0th value will give you index. Okay, the 0th value will give you index, so I'm calling it as index. Similarly, go to sorted nums of I and take the first value will give you nums. That is the value, real value. Okay, this I'm calling as a value. Now I'm going to check whether the current value and the previous value that we had seen in the sorted nums, whether the absolute difference between them is less than equal to limit or not. So see this part, absolute difference of this. Okay, what is this? Absolute difference of the current value, that is certain nums of I of 1 minus certain nums of I minus 1 of 1. See the difference here. It is I, here it is I minus 1. Okay, that is the only difference. Here also it is 1, here also it is 1. Okay, that's the only difference. Certain nums of I, certain nums of I minus 1. This is the only difference, right? So value minus the previous previous sorted value. Okay, in terms after sorting the exact previous value compared to the previous value. Okay, take that and do the absolute difference. If the difference less than equal to limit, then we can say that this particular value is also going to part of the previous group itself. Okay, so we'll take the previous group. How to take the previous group? See, I'm going to do this. I'm just going to take groups of -1. This will give me the last inserted group. Okay, in that, go to the 0. Okay, and add the current value. Okay, remember this is going to be heap push. Okay, this is going to be heap push. Remember, for the first value we did not do heap push because this is just the first value, but from the second value onwards it will be heap push. Okay, as simple as that. This will go heap push. So we are pushing this value. in the zeroth value of the group. Okay, if you see the zeroth value of the group, this is the zeroth value of the group. Okay, and this is the first value of the group. Okay, just let me show this here. See, this is the zeroth value of the group where we are storing the values. This is the first value of the group, that is index number one of the group, where we are storing the indexes. Okay, so yeah, the same thing in the zeroth value, push the value in the index number one, push the index. Okay, as simple as that. Remember, it will he push. So if this is not the case, we can see that now we have to form a new group. So how to form a new group? Just do this. Just do a group dot append. This is the whole array. Okay, in this array there are going to two parts. The first part is the value itself, the second part is the index. Okay, as simple as that, right? And this will keep continuing. Okay, so whenever something is there in the previous is there part of the existing group, that will be added there itself, otherwise a new group will be created. Okay, then I'm doing this print statements. You can just go through them. Okay, okay, let me just show you the print statement also. So yeah, you can just go through the print statements. I've already like shown you the examples. So these are just the same, right? These are just the same. I've mentioned everything to you. This is how the shorter nums is going to look like. And finally, how this is how the groups is going to look like. Something like this, okay? So each group, basically, I mentioned it like this, okay? As simple as that. Finally, now we have to find the answer, okay? This is again going to be very, very easy task. See this part. What I'm doing, I'm going through in the group, okay? There will be two elements. First one is the element heap. The second one is the index heap, okay? See this part. This is the element heap, okay? And this is the index heap. Okay, as simple as that, right? So for each group I'm going, okay, this is the whole group index. There are two parts. First one is the element heap, the second one is the index heap. Okay, so I'm going through element heap comma index heap for each group. What I'm doing, till there is, remember, both of them is going to have the same length. Okay, length of this and length of this are going to be the same. So in this case I've just written, while there is single element present in the element heap, what you have to do, just do, see this part, nums of this index is equal to this value. Okay, nums of this index equal to this value. See, this is the value. Okay, and this is the index. So in the nums array, go to this index and change its value to this. Okay, this is what we are going. Go to nums array. Okay, in this particular index, do like change the value to this. Okay, as simple as that. So what is happening to this part? I'm doing heap pop of index. That is the smallest index will pop out. I'm doing heap pop for the index heap. That is, if you see in this case, what will happen? The smallest index will pop out. That is zero will pop out. Okay. In zeroth place, so in the nums of zero, what you have to do? You have to do a heap pop of elements heap. So if you see, this is the elements heap. What we are popping out, the smallest value will pop out. So one will pop out. So what we are doing in the nums of zero, keep one. Okay. That's what we are doing. In the nums of zero, that is in the zeroth end of the nums, keep the value one. Okay. Similarly, in the index number 4 of nums, what you have to keep? You have to keep one. Similarly, in the index number 5 of the nums, what you have to keep? You have to keep two. Okay, and so on it will be happening. Okay, right? And finally you have to return nums. Since all the values are now changed, you have to return nums. So finally the nums will look like this, right? Yep. So yeah, fun. That was all for this solution, and yeah, I will also go through the time complexity. Before that, see this case. This is clearing all the solutions, but just remember before submitting, okay, just ensure that you are commenting all the print statements. Otherwise, we will get like output limit exceeded error. Okay, even the time complexity sometimes by some milliseconds it will be impacted if you are not hiding your comments and you are simply running submitting the solution even when it has comments. Okay, so just remove that part. Okay, just comment out the print statements like this. Okay, let me do it for you. Then submit the solutions. Okay, and while tracing, you can use those comments, right? So now let's talk about space and time complexity of the solution, right? So if you see what we're using, this is the data structure that we're using, right? So since, okay, for every element it is going to store a tuple which has two elements. Okay, so basically for n elements it's going to store two into n elements, but still again we are, since we are talking about O of n solution, right? O of n means only the higher limit. So again this will be O of n only. Okay, simple as that, right? Even if it's 2 and 3 and 4 and still it will be O of n only, right? So yep. Next is, yeah, we are sorting it out. Sorting will take a time complexity of n log n. Okay, this is another reason why if you see the time complexity, it is going to be n log n. Okay, because this is one of the biggest reason for that, because the sorting is going to take n log n time, right? Next I'm creating a group array, but remember ultimately all the values stored in this group are going to be elements existing. Okay, elements existing in this sorted nums array. Okay, that is the index as well as the value. Okay, so overall this is also going to show of n elements only. Okay, I'm not seeing how many exact elements are. So if you see, there are three direct elements. So this element number one, this element number two, and this element number three. But see, I'm not talking about like that. I'm saying internally how many elements are being stored. Okay, internally how many elements are being stored. So that will be equal to 2 into n, because every number will store and its corresponding index will be stored. Okay, so this groups is also going to store O of n. This is also going to have O of n space continuity only. Okay, this is a for loop, so it will take O of n time. We are doing some heap push at max. See, heap push, it's going to take in a logarithmic time. Okay, so let's say n elements are already there in the heap, it is going to take a log n time. So that's why I've written a logarithmic complexity for them. Okay, but again, like I'm not, see, for heap I have to calculate the complexity different. I will come to that. See here, and then finally we're doing the pop. Okay, even the, okay, just me zoom out. Yep, also going. So just think it in that way. See, every element will be pushed to the heap once, and it will pop out from the heap once. Okay, so each push and pop is going to be log n time. So so for every element, basically, we are going to spend log n time. Okay, for for pushing as well as for popping. So overall, if for n elements, it is going to n log n time. Okay, so the time component is going to be n log n. There are two reasons for that. First reason is that sorting is involved. Second reason is that heap operations are involved. So every element will be pushed and popped once. So for all the elements, if you see, it is going to be n log n time. Okay. Now coming to the time complexity part, see this part. We have maintained this array. It is having n elements. So again, it is O of n time. Even other than that, okay, it even in the heaps, basically we are storing some elements. Okay, even the heaps are storing those elements. Okay, so yep, basically heap is part of this, right? This part of this itself. So this is also going to store O of n elements. Okay, as simple as that. Of n means, see, technically it will be 2 into n elements, because for every number we are going to store its index also. So technically it will be 2 into n elements, but in terms of big O notation, it will be O of n, right? So that's why the space complexity is going to be O of n, and the time complexity is going to be O of n log n. So often that was all for this video. I will again advise you, please go do a Google search and try to remember this topic. This is basically idea. This, remember, this is not a algorithm as such. This is just an idea you have to understand. So in this case, we follow this idea because whichever element belongs to this particular group, we are going to add them. Okay, as simple as that. Because what will happen is, the idea behind this question is that every element in this group can be swapped with each other. Okay, so what we'll do is, let me zoom in again. See, ultimately, every element in this group can be swapped with each other. Okay, that is the basic idea. If I show you this example, right? So all of these, okay, are going to be part of the same group. Okay, if we are doing, if you're doing this algorithm on this, every number will, in this case, will fall a part of the same group. Okay, so what will happen? Since all of them are part of the same group, what we'll do? So these are the indexes for these elements. Okay, so what we'll do? We'll take the smallest index and try to put the smallest value in the group in that index. Okay, so that is how we are going to ensure that this string that is the value that we're going to get is the lexicographical smallest. Okay, if you see the lexicographical smallest definition, that at the first point of difference, whichever, okay, array has the smallest value, that will be called as a smaller in terms of lexicographical sorting. Okay, for that reason, we have to ensure that the smallest, the initial indexes are having the smallest value. Okay, so for that reason, what we are doing is, these are the interchangeable ones. Okay, just a second, these are the interchangeable ones. So we are going to push the smallest value possible in this group to the forward-most index. Okay, that is our logic, and that's how we are applying it. So often that was all for this video. I have tried my best to explain the solution. If you're not able to understand, please pause the video. I will say that please rewind the video and try to understand this part. See, before making these videos, like, I have done a lot of calculations on myself. I know what to speak and like what all to include in my video, so that you can get a complete picture. My always aim is to provide you complete information, right? So please believe me, I have provided everything that is needed to understand this topic and to like learn this video. Okay, I've given a hands-on example also, so that you can understand everything. But I agree that I have not given you like a total idea of this. That's why I mentioned, you see, just do a Google search, you'll get to know something about it, and then maybe you can come back and see in this video, you will learn the application of this topic. Okay, this topic is named disjoint set union. Exact same thing, you can do a Google search and you will get multiple results. Okay, this is also called as union find. In LeetCode, you will find this name, basically union find, but yeah, in some platforms they will be using this name. Okay, so they are interchangeable ones, right? Just remember that. And in this question, we are using heaps. Because of that reason, this is the complexity. And also another reason is we are using sorting. Okay, for the reason also, this time complexity is coming. Yep, that was all about this video, friends. And yep, we can also think about the brute force solution. And as I mentioned, bubble sort is something that you can come up with, but again, it is not effective here, because here we are not talking about swapping between the adjacent elements, but any element can be swapped. Okay, for that reason, it's more about finding a union. Okay, finding a union of groups. Okay, that's why the name is disjoint set union, because we are finding sets, and ultimately we are combining those sets to get a union. Okay, so basically all the elements in a set is interchangeable. That's what the idea here is, and we are ultimately doing a disjoint. Okay, we are doing a union of this. We got the whole answer, right? As simple as that. So often that was all for this video, and this was a FAANG level question. I will again say, see the acceptance rate. This acceptance rate, if you are someone who is very I can say experienced in LeetCode, you will get to know that this much acceptance rate is showing that this is a very hard level question. Okay, like currently it is 55%, but like when the morning I saw, this was around 51, or yeah, something like, it was around 51%, right? So this was something that I want to teach you. This is a FAANG level question. If you can solve this kind of questions, you can clear FAANG level interviews. That is something that I want to tell you, that just try to come to this level once you are here. But remember, you have to explain everything. That's why in my videos also, I always try to go from the scratch till the above. Okay, that's why I mentioned first bubble sort approach, why it is not useful. Then we came to this particular idea, disjoint set union, and then we started applying it. Okay, as simple as that. So what we're doing, we are basically trying to find sets, okay, which are going to have the same property. That is, we're trying to keep elements in a single set which are behaving in a similar way. Okay, this is like a set. Okay, and if you take the union of all these sets, you are going to get a disjoint set union. Okay, that is the basic idea behind them. So upon that was all for this video. And if you like my efforts, please do subscribe to the channel. This really gives us a lot of motivation to continue further. And yep, my always aim is to provide you quality content, so that okay, you don't have to go to various websites or videos to learn the same thing. My aim is to provide you the complete information in a single video, and I also try my best to keep this video short, so that you don't have to spend much time. Okay, because many people will feel like, oh, if it is a 30-minute video, let me not watch it if I can get a 5-minute video. So, but see, my aim is to get you a complete picture till I believe that I'm not giving that complete picture. I like keep explaining. Okay, so that's why sometimes the video gets longer. So often that was all for this video. If you like this approach, if you like this coding style, please do subscribe to the channel. This really gives a lot of motivation to continue. Further, it takes a lot of efforts to create this kind of videos to explain everything in detail after taking time out from my regular job. So often that was all for today. Please subscribe. See you tomorrow.